thank you, Livable, Buckhead, and ULI Atlanta for inviting me here. I'm very honored to join you to imagine a climate positive future through a pioneering vision that you guys been talking about here, which is one of the first low embodied carbon district, if this happens. I'm Teresa Jan. I'm the director of the Climate Positive Design at Multistudio. So it's a little bit about me. I'm an architect. As an urbanist and architect, I advocate for net zero carbon development. On my work and speaking and writing. And on my spare time, I grow vegetables and herb in the community garden. I also been doing quite a bit of learning from our Native American community. So the picture here is me visiting a sustainably managed forest and mill, and they've been trying to revive prescribed burning. So very relevant to what Elsa Joe was just presenting. A little bit about where I work. Multistudio, we are a nationwide design collaborative working on the pursuit of possibilities. We work on very diverse typologies and scales, and what matters to us most is the impact to communities like yours. As our nation burdened by housing shortage, Multistudio has been partnering with developers, universities, not-for-profit, and contractors to do diverse housing projects. It could be market rate, student housing, affordable, and perhaps now workforce housing. That's really popular. Most of the developments are transit-oriented and amenity-rich. Mezzanine Square on the upper left is a passive housing-inspired student housing that have zero net operating carbon, let's say. The picture below is a Spartan Village, which is a hotel to student conversion that got designed and built under 1 year, which was an amazing time frame. And because we use the existing structure, we avoided about 11,700 embodied carbon by just putting housing onto the market. So here are the 3 buckets of topic I'll be covering today. One is what is climate positive design? How do we kind of design with that? The second would be the practical strategies of deploying low embodied carbon design. And then third is how do we collaboratively work together to be low embodied carbon development. So climate positive design is really just a holistic approach to think about how we build, how we design to promote social equity, economic mobility, and climate justice through this idea of decarbonization, design, implementation. It's not complicated, it just had to think holistically. So first, we talked about energy and water efficiency. It's always good to reduce, reuse, and then renewable. So I always talk about let's prioritize the passive design strategy first. Let's invest more in building envelope because it lasts much longer. It lasts 50 to 100 years, longer lifespan compared to the active building system, such as a MEP system that only lasts about 15 to 20 years. And then once you can really lower that energy consumption or water consumption, then we look for a way to offset it. We use the water, we offset it with renewable, such as solar, which is much cheaper now too. Second is to design with healthy and low embodied carbon material, which is what we're really gonna focus today. This is much like eating smart, right? We've been talking about let's try to eat fresh produce, locally produced, with, that might be produced by your local regenerative agriculture farmer, and let's minimize the intake of processed food. That's what we package. So it's the same concept. Like we really want to we build with bio-based materials such as mass timber, and then that inherently really being produced by less energy and water and less of those toxic chemicals that we don't want. We also should aim to design with less than more, right, when it's possible. So you really reduce that building material quantity. We prefer to design with product and system that allow us to disassemble at the end, like mass timber as well, because at the end of life, when building the alteration or renovation or disassemble, you could actually be able to divert some of the material be reused rather than go to landfill, which is support this whole idea of circular economy. Last lastly, I also want to emphasize the importance of carbon drawdown through our native landscape, restoration, and urban green infrastructure. This is to reduce the heat islands, this is to increase the permeability, prevent flooding. It also really promotes this idea of biodiversity, right? That gives us more resiliency and help out on carbon sequestration. So when we design and build with this sort of combination of authentic design strategy, people will actually experience it, right? Like when you walk into a well-insulated housing unit, it's just, you can feel the calmness, it's quieter, it's well-crafted. When you go to a biophilic office, kind of like one of being presented, people feel happier and much more productive because of light and air and this sort of tactile experience that they can experience. And obviously your public plaza, your public spaces will be full of biodiversity and people, and that's where you make your district very vibrant. So I just kind of want to think about that when we build building right with all this strategy. We're really enticing people with this sense of joy because they cohabit with it. So let's talk about what are the simple and practical low embodied carbon design strategies. You've been all heard of using the booklet, you've heard about 11% of our carbon emission is really dominated by the energy that will create building material. So here is a sample building embodied carbon type like donut chart that talk about what embodied carbon goes to different components of the building. You can kind of see the structure take up usually more than half of the entire building embodied carbon. And really talking about embodied carbon design, it's really require a whole team of commitment and evaluation. We usually want to prioritize retrofit first, right? The greenest building is a building that's being built. We want us to use the low embodied carbon materials such as low embodied concrete, steel, mass timber. We want to maximize the structural efficiency so that the building is lighter. Kind of what we talked about earlier, you want a lighter building so you can have lighter foundation. And we want to build less with more. So the good thing about mass timber and some of the building material is that if you put it in a well, you don't need to have another layer of ceiling to cover it up. That also adds up to the embodied carbon. We talked about component of the building not being able to disassemble. So with the fast, so that the material can be repurposed, reused, and things that go to landfill. We cannot improve if we don't measure, right? And we kind of learned that over the years. So this ideal life cycle assessment is really pushing us to think about the whole life cycle of the building material and be able to quantify it. So the good thing with sort of policy mandate and advocacy and also the market demand, more and more EPD are out there now, at least from cradle to gate. It always specifies the global warming potential in EPD. And a few manufacturers actually have met providing product-specific or factory-specific EPD as well, where they have multiple lines and multiple manufacturers. So based on analysis of 36,600 product EPD, Carbon Leadership Forum have published this booklet called North American Material Baseline, August 2023. It has been serving as a reference guide for our industry. So you can see the graph on the right side. You see all this light blue dots marching along the strata of global warming potential that's ranging everywhere, and then put a little like red cross in the middle or somewhere. That's the so-called baseline. That is helping us to compare all the different product EPD that we're coming in, and we're just trying to look for the product that have lower GWP compared to that baseline that is set. So let's look at how do we specify low embodied carbon concrete, right? EDC. So every project, no matter if you build with steel, mass timber, or concrete, you always have that concrete foundation. So that's why it's important. And foundation, also the vertical concrete component are easier to have pursue low embodied carbon because you're not fighting the curing time for that critical construction schedule. So what we can all do is ask our structural engineer, I don't know, structural engineer in here today, is to specify to specify a high SCM material mix, so you can substitute with fly ash, slag, blown zones, all those different kind of substitute material. I think the crucial thing is, and we also have a contractor here as well, and I think there's a concrete cement supplier as well. The best thing is to get them to talk to each other early. Bring them on board early. Try to find a cost-neutral way to figure out how, to maximize your reduction of your entire building, entire structure. I think that's a healthier way to find the best solution for your project. So looking at the material baseline, they gather about 1843 applicable EPD just within the Southeast region and categorize them by the final compressive strength at 28 day. So compare that map, you could see, and the base, compared to that map, you could kind of see there's quite a bit of the concrete plant around Atlanta. Just for example, the average of 5,000 PSI concrete is 360 kilogram CO2 equivalent. So the sample EPD to the right show that in Alabama, one of the plant, they produce a concrete that for that specification at 251. So this is pretty encouraging, right? It's readily available. You just have to ask, really, and have to look. And let's take a look at the carbon, low embodied carbon steel as well. So the first rule is to specify steel that made an electric arc furnace. We call it EAFs. The EAF process is really a steel making with electricity to melt the scrap metal into a molten steel. It significantly reduces steel embodied carbon. Good thing is 70% of our steel plant in America is using EAF technology. So again, ask for high recycled content, and that's pretty typical practice as well because steel is scarce. Most of them to do that. So let's look at the number and the map. The map on the right shows that this various steel bar, beam, plate, sheet, EAF plant all sprinkled around Southeast region. And you could kind of see that the baseline of, according to the material baseline, the average open steel joist is 1.4 kilogram. And then you can see that the published list by AISC, most of the open web steel from various different plants are all below that. Some of them actually achieve 50% reduction from the baseline. So this is very encouraging. Well, I want to say that the EPD published for glazing, cladding, carpet, flooring. I mean, by now, there's tons of them. And if more is demanding for it, the market is shifting that way. They're just going to be more EPD available, just like the food nutrition level, that label that we see on our food consumption now. All right, so to achieve a low embodied carbon really require a close collaboration with everybody involved in there. There will be the developer, design team, contractor, everybody, the supply chain all have to get there. It's good to get literate, just like all of you guys being here. Some people have been working on 15 years, some people are less, but we can all work together, contribute our perspective and our resources to make it happen. So I'm going to show you a case study of a project that we're currently working on right now, show how we set the baseline, how we try to aim for the sky, and some of the what's everywhere. One of the projects we're working right now is a high-rise housing development. I'm going to focus more on housing because that's what I heard was going to happen in Buckhead. It's a 500-unit housing with 10% inclusionary housing, sort of like a middle-income housing in there. While the owner, developer, and the local jurisdiction doesn't really mandate for low embodied carbon, our design team be kind of working hard and thinking about all the different factors. To set the baseline and devise reduction strategies, we use the open platform, a free online tool that you guys can have access to. It's called C-Scale. It allows us just type in zip code, project size, typology, give a little few parameter. It will help us to set a business individual baseline, which is what you see on the slide. I want to point out a few things. You can see that the amount of embodied carbons that we we all use for day one when the building open is more than the combined operating carbon over the life of 60 years, right? And the operating carbon is our electricity, fossil fuel, refrigerant that really keep the building running. And you can see that the red color, the embodied carbon, tend to go up a little bit every so often. And that's just because the material and building system had to be replaced or maintained every so often. So you kind of jump into 15 or 30 years. But if we were going to elect all the aggressive low embodied carbon strategy and climate positive design strategy by going all electric and all the low embodied carbon refrigerant, building material and system, you can see that over the lifespan of 60 years, we could actually reduce more than 50% if we're really aggressive, right? This is kind of what we're gonna try to see how we can shoot for this guy. And then the difference in embodied carbon reduction alone itself could be about 25 tons of equivalent. This is, putting the perspective, this is equal to taking 6,000 gasoline car off the road, or about amount of carbon sequestered by 25,700 acre US forest, right? This is huge, so like, why don't we try it, right? If we can make it happen. Like the simple donut chart I showed you earlier, I just also want to point out that the structure elements make up 50% of the total embodied carbon on the module A1 to A3, so that's the cradle to gate. This is the carbon that's spent on just producing the material. Interior material, the orange part actually ranks second, and then building system and the cladding. So I want to point out interior material make up a bit of embodied carbon because there's 500 units, there's a lot of gypsum, a lot of casework, flooring, finish that go into it, right? So it does add that even just thinking about interior wise. We should know that the energy that's spent and maintain the replacement of material over 60 years add up quite a bit too. That's the B2 to B5. It's not as high as the operating energy, but it's there. So that's why durability of your finishes is also important. You want to be able to not have to replace material often. So obviously, as an architect design team, we were so excited. We were like, hey, let's make this all possible. We started looking at cladding material, thinking about how can we choose a responsible embodied carbon cladding. So we looked through different options, generic option that's been published on another website resources. We thought the precast concrete seems to be aligned to our concept design of the scallop fluted concrete facade articulation that we wanted, but still quite low in terms of GWP compared to other material. Then we went on designing, but then at the end of SD, the structural analysis and cost estimate told us that although the precast concrete cladding have less GWP, that it's not heavy. It's putting quite a bit of burden on our structural system. And that, when we run more analysis, structural engineering estimated that by switching to a lighter cladding, such as aluminum composite panel, and just fine-tuning the core geometry compared to the overall building geometry, we could actually reduce 10% of cement being used in this building. And that definitely contributes to cost saving as well, right? So it's sort of the V of the embodied carbon and V of the construction cost as well. So the lesson learned is that communication is key to incorporate all the discipline. We can't really all work silo. We really have to have constant communication and work closely to evaluate the big picture early. So we're lucky we're still sort of in a very early design strategy stage. Right now, our structural engineer is really finalizing the structure calc and embodied carbon estimate while we work really closely with the interior team to kind of make sure that we all select the low embodied carbon and healthy material that's durable so that we can continue to maximize our embodied carbon according to the quantity goal that we set it up to be. I know we covered mass timber earlier, so I don't have to dwell too much on this. But what cool thing about the mass timber is that it's something that people could experience, something people could see, right? Like if you talk about low embodied carbon concrete, most of the people people to walk into the building before they actually experience it. And I want to point it out is that I know that there's another Goodland manufacturer now, just 2 hours away from here in Greenville, South Carolina, and due to the regions that often South and West Pine. So this is sort of an opportunity for you all to capture. Here's a map to show mass timber building growing just like the timber right now, and this map only show tall timber or hybrid wood construction building that focus on housing right now in the office. So just kind of putting out there for you guys. There's some really great case study out there right now that make good business case for housing. So Aspen in Milwaukee, Wisconsin is 19 level of housing over 6 level of parking. 45% of the unit were pre-leased at the construction, before the construction completion, right? And according to them, the construction costs were the more expensive, and that's setting a really high rate record of the apartment rate within the city. Intro and Cleveland, Ohio is an 8 level of a 1-story concrete podium with 300 apartments. 60% of the apartment were also pre-leased during construction. And you can kind of see people get really attracted to the COT, exposed COT ceiling, and sort of that comfort battlefield kind of feeling. Barracuda is a condo building, so they were built earlier than the other two I showed you before. So the sales velocity was astounding. 75% was sold at the start of the construction, and 95% was sold before the construction finished. If you want to learn more about the case study, we'll work on a whole bunch of application. Reach out to me, I could kind of share the links to you. Earlier, we talked about incentive. I understand there's no more incentive into the FAR, into the zoning, but I want to point out that there are financial incentives out there right now based on the commercial PACE product. There are products out there that lend lower interest rate loan when the building demonstrates both energy and water saving, and also they allow you to use low carbon concrete as a way to kind of meet their criteria. Well, my last bit of call to action is that when developers select architects, or when architects select our consultant, we really pleased with the group for the professional who have pledged to make net zero carbon development and have been making progress. And I know landscape architects are working on their program, and I really hope that contractor developers will also kind of pledge on this mission and goal, because you really take all of that to make a low embodied carbon development happen. So thank you guys so much.
Thank you.
Thank you.
All right, so everybody, we're going to take